Hi, hello, good evening everyone. Welcome to Gradeup. Welcome to the session Score Boosters series. We are almost at the end of the session, guys. At the end of the series, sorry. We have started this series almost a month ago, and we were discussing algorithms, computer networks, computer organization, operating systems, data structures, right? I tried discussing about the most important, most frequently asked topics, and I believe the sessions that held so far helped you, and they have added some, they might have added some value to your preparation. Okay. Today and tomorrow we will just keep briefly revise the things that you should mark as a checklist. Like before you wind up your revision and before you stay calm, means just one day before the exam, we generally suggest you don't prepare anything. So before that, what you are supposed to prepare or what you are supposed not to leave. Today we will be covering the data structures and algorithms part. That's why we have marked it as a quick revision of DS and algo. Okay, and I can see students joining: Indrani, Shiva, Raudra, Anugrahit, Akshay, Prakhar, Premjeet, Mayuresh, Mukhal, Pavan, Aprajita. Very good, very good. Good evening, guys. Good evening, everybody. Welcome all again. So let's get into the session, guys. Before that, let me tell you very clearly, in the sessions what are held, I tried in the time that we have, what best I can do, that already over. Today I will not be explaining any concept. Please understand. Today I will not be explaining any concept, rather I will be giving you what topics you are supposed to prepare, and quickly I'll tell in that topic what you are supposed to prepare. So mostly we would be covering what part today, how, why. We will address very less. Please understand the motto of this session. Okay? Okay? Fine. So we just have more 4 days, just 4 days. Mayuresh, I'll give you, I have promised yesterday that I'll give time complexities for you. Definitely I'll give you. Okay? Yeah. First, this is what the expected weightage for 2020 GATE exam from data structures and algorithms. Guys, it is better, I advise you guys to keep a pen and paper with you, and please make a note, because every time replaying this video, it's time consuming process. Rather, if you just make a note of the points that you feel important, all may not be important, some points you may know. So what points you feel not to miss, what points you feel very important for you, which may help you, please make a note of it. So this year the expected weightage is let us bound to the lower bound. Let us bound. Okay, 10 marks. It is my personal prediction, because I am not just giving it randomly, guys. As a faculty, definitely we will have some analysis. Like I have reviewed the past 15 years of papers, in fact 18 years to say, and the past IIT Delhi paper. So with some proper analysis I am telling this count. Okay, and I am not telling this would be the perfect weightage, exact weightage. That's why I wanted to be on safe to give you some range. So you please understand or take the lower bound of the weightage that I am giving. So from data structures you may expect 10 marks, and from algorithms you may expect 4 marks this time. Okay? So your aim should be, out of this 14, I should get 14. If you have prepared these 2 subjects, if you have selected these 2 subjects here for your preparation, then give 100%. Because I always suggest you guys, don't prepare all the subjects. Because everybody or nobody can be perfect in everything. So don't try to put your legs on all. So pick any 6 subjects. This is what my regular statement. So if these 2 are in your 6 subjects that you have picked up, you give your 100%. Try at least. Okay? Now let me first take you through programming and data structures. Then after this we will take up algorithms. Okay? So first I'd like to present priority of topics weightage wise. That means what is the mostly predicted topic from which questions may come. Next, what is the priority? Next what? So I believe everybody can understand this title. Priority of topics weightage wise. Okay? So this is what the table that I have prepared for you. That is, first from the data structures you focus on trees. Trees means, just yesterday I have covered this. Binary search tree, heap, tree traversals. That's it. Guys, I am telling you what not to miss. If you have acquired something more than this, it is really appreciated. You know even more than what I am telling, it is really appreciated. I am telling what is minimum for you to prepare before GATE exam. Okay? Try to understand. Now, so binary search tree. You know what is its characteristic, left, right, etc. Right? Similarly, heap. So what is the difference between binary search tree and max heap or min heap? So how you can insert an element, how you can delete an element. Because yesterday we have seen, we have GATE questions multiple times about that insertion, deletion. Like if you insert, this is what the current heap. If you insert 3 elements, what is the result? If you delete couple of elements, what is the result? Right? And after insertion, what is the traversal? After deletion, what is the traversal? So questions are like that in GATE. So it is worthy preparing heap. And then traversals, in order, pre-order, post-order, though they are relatively, comparatively easy, but there is much probability for this topic to frame a question from this topic in GATE. So guys, don't be overconfident about tree traversals. Please understand what I am telling. Please be attentive. Please be attentive. Please be cautious while attempting tree traversal questions. Because in order, pre-order, post-order, you might have practiced, but there is much probability to commit mistakes by overlook, in hurry. So while attempting easy questions, be more attentive. This is my statement. So attempt easy questions or simple questions with more attention. Generally people say give more attention to difficult questions, but my recommendation is different. Then time complexities for operations on data structures. Why you may get a direct question, what is the time complexity of so and so? Or you may get some match the following question, giving some data structures or their operations on one side and the corresponding time complexities on other side. Or some time complexities can be given for you and they may ask you to arrange them. They may ask you to arrange them in the order. Guys, for this session time, how much I can give, I have planned. And if you want something more extra, there are previous sessions of data structures. Even there is a ISRO free series in our Gradeup channel, in the Gradeup app also. There also I have discussed data structures. There I have done the similar session from ISRO exam point of view. So I advise everybody to please go through the ISRO series of videos also. If anything you want more information, there you can get. I have tried my best in putting the things in today's video as much as possible. If you still want more, please refer that ISRO free series also. And the next most expected topic is recursion. So recursion questions. I have done one special session, special video we have made, special class we held, which was held especially on recursion. So if you refer that video, that session, you can find all recursion questions, all recursion based questions. So that is a good form of revision for you. So you need not to again go around all the sources. You may not to refer some books. You may not to search. I have done all that work for you already. So just refer that video, see all the recursion based questions, and estimate, judge yourself, evaluate yourself, assess yourself. Are you good at this model? Are you good at that model? So what models you are weak at? You can understand yourself. So only you make a separate sheet, which topics, which models you are strong at, which models you are weak at. Do it after this session, do it today itself. Because you don't have more days. Do it today itself. What I am telling you, just implement it today itself after my lecture, after my video. Will you do that? Students, please respond. Will you do that? Good, good. And Himadrika, actually I was waiting for you, man. Himadrika Sinha, I have seen your email and you have presented 4 questions and I will answer those questions personally to you over email. Himadrika, okay? Then, what is the next most predicted topic from which question may come in today in this GATE, this year GATE? Character pointers or strings. Okay? Then stack, infix, prefix, postfix, conversions, and evaluation of postfix expression, because these are 2 popular applications of stack. Infix to postfix conversion, postfix expression evaluation. Okay? And finally, storage classes, which are static and extern. And I think we have doubly linked list. Yeah. And doubly linked list. That is final. So guys, here you can understand the syllabus that is there in data structures itself is simple. And I tried making it even more simple. So you just make a checklist. Are you good at this? Are you good at this? Are you good at this? That's it. Your DS revision is done. Trust me. Trust me, guys. Your DS revision is done. If you are good at these topics theory, you are good at these topics previous year questions, you are good at these topics all model questions. Okay? Have you noted this? Please note all this. Then as per the request of the students, I have taken this. I'll give brief of all. Okay, don't worry. So first, operator precedence and associativity. From this question, probability is less, but there is a probability. So what is this operator precedence? You all know, if I say A equal to 7 divided by 3 power, means this is exponentiation, 2 logical bitwise AND, 5 logical AND, 4, something like this. Some expression is given like this. And the question is, what is A value? Then comes the necessity of operator precedence and associativity. Then you might think, array, yes, I have missed it. Array, I forgot it. I know it, but I forgot it. Because you have not revised it. Because you have not looked at it before the exam. That's why let us not take a chance. I'll give you very simple way, guys. For remembering operator precedence, please remember this code. That is U, A, S, R, B, L, T, A. And if any one of you have attended my ISRO free series, there also I have given the same code. It is very easy, guys. Here U says unary. Unary operator is always on the first priority. Arithmetic, shift, relational, bitwise, logical, ternary, and assignment. So which has at the least priority? Assignment has at the least priority. So U, A, S, R, B, L, T, A. It's not so tough to remember. Your brain is capable of remembering many things, I know. You are so capable. So use your capability to remember this, guys. It will help you. Okay? Now, if you still can remember much, then do this. Do this. In arithmetic, multiplication, division, modulus have same priority. Addition and subtraction have later priority in arithmetic. So you try to remember how much you can, okay? And similarly, in relational operators, less than or equal to, greater than equal to have high priority, equal to has next priority, equal to of course not equal to, has next priority. And in bitwise, XOR has first priority, bitwise AND has next priority, bitwise OR has next priority. Okay? XOR and OR. And under logical, AND has first priority, OR has next priority. Then that's it. So what more you have to remember? Just these couple of things. Okay? Now let us discuss about associativity. When associativity matters? When two or more operators with the same priority exist. For example, here of course there are no, if I just edit this like this, suppose if I just edited this expression like this, here the division operator, multiplication operator has the same priority. So which one to perform first? Then priority cannot decide that. Associativity comes into picture then. So please remember, the associativity for many operators, associativity means direction. in which direction you are supposed to do. Many operators have left to right. So I'll just list here what have right to left associativity. So the left are, whatever are left, they are all left to right. Okay? Whatever I have excluded, whatever are left means. Okay? Now, what have right to left associativity? Ternary operator has right to left associativity. Assignment operator has right to left associativity. Unary operator has right to left associativity. Unary, ternary, assignment has right to left associativity. Remaining all have left to right. Simple, right? So follow this order. Try to practice couple of questions, not more than that. You try to take some expression on your own like this. You try to evaluate the result, and how you can check is it correct or not? Simple. Type that in the program. Execute it. Output you will get. Computer follow this priority, this associativity. So computer will give you is it correct answer or not. Okay? Now, the next is storage classes. What a storage class means? Suppose I have declared int x. Now I am trying to print this x value. Did I give any value to x? No. So whenever user did not assign any value, what would be the default value for any variable? So what is printed? Then see here. How many bytes of space is allocated for this x means we say as it is integer 2 bytes for 16-bit processor, 4 bytes for 32-bit processor. So we say that. So size doesn't matter. Size is not defined by storage class. Then where this 2 bytes or 4 bytes is allocated? Because we have different forms of memory in the computer. We have cache memory. We have primary or main memory, RAM, ROM. We have hard disks, right? We have registers. So in these many forms of memory, in which memory for my x space is allocated? So what is the storage location for any variable? Then whenever I have created this x, when I write this x, when I write this int x in this block, whenever this line is executed, so this is the moment where we say x is created. Now the question is, this is the point where x is created. So x born now, x born at this point. How long it exists? So what is the lifetime of a variable? And if suppose you have multiple functions in the program, here you have created x, here you have created y, here you have created z. Now question will come, can I access this x in this block? Can I access this z in the other block? So which variable, where it is created, and where, till how long I can access it. This is called scope of the variable. So storage class defines these 4 for the variable. Okay? Storage class defines these 4 for the variable. Now, what are different storage classes we have? Auto, register, static, extern. These are the storage classes. quickly I'll give you those parameters. Quickly you write auto, register, static and extern. I don't take more than 2 minutes. You can calculate. Auto default value is random, garbage value. Even for register also garbage value. For static and extern, the default value is 0. And what is the memory location for auto? RAM or main memory. For static, RAM. For extern, RAM. Only for the register storage class, the memory is CPU registers. And what is the scope of the variable? If it is a auto storage class, the scope is local scope or block scope. That means in which block you have defined, in that block only you can use this. Similarly register, similarly static. But external storage class has file scope. That means throughout the program anywhere you can use. And finally lifetime of the variable. Auto register storage classes have the lifetime within the block. That means until the control is within the block, within its corresponding block, that variable is alive. Whenever the control goes out of the block, that variable is dead. But static and extern have throughout the program. Their lifetime is throughout the program. Until all program gets executed, those variables are alive. So this is what the information about storage classes. Now quickly let me give you one simple code. Let's say this is main. Guys, don't try to identify syntactic errors. I am writing the pseudocode form. Please understand. Okay. Now for I is equal to 1, I less than 4, I plus plus. Let's say I am calling one function A. I am calling one function A. Okay. Now what is this A? Static int x, printf and let me do x plus plus, printf x is equal to %d comma x. Okay. Guys, don't try to understand, identify the syntactic errors. Don't say, sir, I is not declared and all. Okay. Now, please observe when you execute, what is the output? This is one form of GATE question. Of course, it has come with little complexity, not this simple way, little complexity. If you understand this, you can understand that. What is this thing? When I is 1, A is called. Static int x, x is created. Have you given any value? No. What is the default value? 0, because it is static. Now x plus plus, x becomes 1. Print x, x is equal to 1. Control is over, function is over. Now control is leaving out of the block. Now will this x is available, alive or not? It is alive because this is a static. Because static lifetime is throughout the program. Right. Now control come back here. I becomes 2. Function A is called again. Now static variable will always be initialized only once. So directly x plus plus gets executed. X becomes 2. That is printed. Again executed. X becomes 3. Printed. So this would be the output for static. In the place of static, if you keep auto or registered, what would be the output? Every time x is created. And have you given any value to x? No. So every time it will take some garbage value. So what is the output for auto or register? You can't say. Suppose I have given, I wantedly initialized it to 0. Then what would be the output always? X is equal to 0 and it becomes 1. Now while the control leave the block, when it is auto, that variable is destroyed. Again when you call this function, again that variable is created. So x equal to 0 becomes 1 again. So every time it will print the same value. So like this guys, you can understand what is the difference between the static and auto. Okay. Let me move on. Now the recursion. So guys, I have already made a special series, special session on this. Please refer that. However, you know what is recursion process. A function calling itself is called recursion. From recursion, what you are supposed to practice is, what kind of questions you are supposed to practice is, how many times any function is called. This is one model. How many times any function, some function is recursively called. Then what you are supposed to find out, how many times it is called. Second, guys, I have given storage classes explanation because I have not discussed it in our score booster series. That's why I have given with some simple example. I have explained with simple example. But this recursion part I have already done. So you have opportunity to refer that session. That's why I am not going with examples or anything. Okay. So how many times the function is called? Second, what is the output of the program? Like there will be some recursive code will be given and you will be asked, what is the output of this? So you should calculate, always practice solving recursion based questions by drawing recursive tree. By drawing the recursive tree, always you practice solving recursion based questions. Don't do calculations in the air. Okay, function is called, that is called, this is called. Guys, you are not babas. There is no magic, nothing magic happens here. In the air, don't do calculations, put it on the paper. That's why you will be given the scribbling pad. So put anything that you are thinking on the paper. That saves your time. Believe me, that saves your time. Okay? So try to draw the recursive tree. Something like this. F of 4 is called. This is calling f of 3, f of 0. F of 3 is called. This is calling f of 2, f of 3 minus 4, let's say minus 1. Like this, you draw the recursive tree first. Then you can understand when this is completed, what it returns, to whom it returns, what is the result, etc. This would be easy, guys. So practice this. Recursions based questions, you try to execute, solve using recursive tree. Okay, and then finally I have not discussed it, but I will not discuss now also because it takes much time. That is, it is possible to ask you write the recurrence relation. Write the recurrence relation. You might be given some recursion based program, just 3-4 lines of recursion program. You might be asked, what is the recurrence relation for the given code? Guys, I did not teach this, so you find some source and try to learn this if you don't know it. Okay, and please don't forget this. Don't forget this. And finally, time complexity. So from recursion, these are the 4 possible ways. You might be asked the recurrence relation. You might be asked how many times any function gets executed. You might be asked what is the output, and you might be asked what is the time complexity. Guys, are you making a note of this? Please do this, and please inform your friends. Guys, I want to see you today at any cost. I want to see you 100 watching this video. 100 should watch. Please inform your friends. Let it reach many. There is no selfishness here. Please understand. I want to help many as possible. That's it. Okay. So this is what about recursion, guys. Now, character pointers. What character pointer is also called as string. Guys, I personally just, it is coming to my mind that like it is my most prediction that you will be having a question from this today. I mean this GATE 2020, you will have a question from this character pointer or string. I personally getting that sense. So strings, from strings, how you have to practice? First, hold. Please understand the theory part of strings. Theory part means what? Not what are string manipulation functions, strlen, strlwr, strupr, concat, copy. You are not writing any essay question answer, right? Not the string handling functions. You should understand how they execute. When you write strcpy of s1 comma s2, many students confuse, will s2 gets copied into s1 or s1 gets copied into s2? Or even if you know now, in the exam you may confuse. Similarly, if you are given with some concatenation, many students will confuse. Guys, all your doubts please mail me. This is not the doubt session at all, please. Understand. I want to help you in revising what topics you should not miss. So, understand the intention. Any doubts, you can mail me. I have given the mail ID. However, I will tell again, satya.narayana@gradeup.co. Okay? Please mail all your doubts. I will answer each doubt personally over email. So, many students don't know at the end of S1, S2 gets added, or at the end of S2, S1 gets added. This is what I am telling means. It's not strcpy, it copy one string to another. No, theory, not that kind of theory. How they behave, that you should know. This is first point. So about string handling functions, you please have a clarity. Second is you take a string. You take some string, let's say GATE 2020. Now, you assign some pointer to it. Let's say the string is S. So, assign some pointer to it. Char star P is equal to S. Now, it is very frequently asked convention that 2 of P, P of 2, right? P plus 2, P of 2, P plus 2 both are same. All are equal. So you practice questions with these formats. So when you practice this format, if you get a question, what is the output, you can easily say. Okay? So these are the two things which you should remember to revise about character pointers. Okay? Then stacks, infix, prefix, postfix expressions. A plus B is infix, plus AB is prefix, AB plus is postfix, right? But the thing is, here what you should know, basically 2. What? Infix to postfix conversion. Second, postfix expression evaluation. Infix to postfix conversion is one, postfix expression evaluation is the other. These two. So, for both you use the stack. So, if suppose you are given with some infix expression like this, 2 plus 3 multiplied by 5 divided by 8. What is the equivalent postfix expression for this? We have a procedure. We use the stack. We scan from left to right. If the scanned element is an operand, write it to the result. That is 2. Output is 2. If the scanned operand is operator, put it on the top of the stack. So we have some procedure. So revise this. Revise this. Okay? And try to solve. Revising means not looking at. It's not a movie. It's not a movie or video to watch multiple times to give more views. No. Revising means solve it again. Solve it again. Okay? Then you will understand how much time it is taking. So here it is, everything is related to time. Now, postfix expression evaluation. So if some postfix expression is given, something like this, 2, 3 plus 5, 8 minus divided by. Some expression is given. So what is the result of this? For this also stack is used. This also has a procedure. So scan from left to right. Everything you now push on the stack. So 2, 3, whenever you encounter any operator, then execute them or perform that operation on the top of the stack element and the very next element. Like this. Postfix to prefix, prefix to postfix will not come. That use Q, but that will not come. Don't worry. Okay? So about stack, this is what you have to follow. You have to revise. Infix to postfix conversion, postfix expression evaluation. Okay, guys? Then doubly linked list. Then doubly linked list. Sir, doubly linked list is very complex topic. What to prepare? See, I'll just brief it very quickly. Every one of us know what is a doubly linked list. Like every node will have 3 parts. One is data, other is the next pointer, other is the previous pointer. Right? So let me call these elements as A, B, C. So A has data, B has data, C has data. So how you have to revise? That is what I am telling you. Revision means not reading. How you have to catch the concept means you try to draw some number of nodes like this. Now when I say A next, what comes? When I say C previous next, when I say B next previous, what will be printed? If I put these statements in the printf statement, what will be printed? Got it? And once this is done, now you allocate one pointer. Now you assign a pointer at the beginning of the node. We all know head will be always there at the beginning of the node. So the last element next points to null and the first element previous points to null. So this is all theory concept I think every one of are aware of. Otherwise first you get to aware of that, get to know about that. Then you you on yourself, you try to write some print statements and you first predict what will be the output. A next, B next, C next, or A next previous, B next previous, B previous next. So different combinations, right? So all these combinations you try. And sir, how I can confirm the answer? Guys, computer is there for you. Even in your mobile also you have the compiler, C compiler apps. Just execute in a program, just execute printf statement of this, whatever you have tried, that gives you what is the output. Again here I agree, different compilers give you different outputs. So what to trust? Guys, you please do not trust online compiler output. You better install dev C compiler or GCC compiler. Either of these two you can take as standard. Okay? And finally, trees. Again, if I tell all this about trees, it would be like a repetitive session of yesterday's, right? So what to focus? I already have put that in the table. First, get to know the definitions. Yes, I know you are not going to write any definition, but you should know the definitions. It doesn't mean don't by-heart the definitions, don't mug up the definitions. That is not what I am telling. Understand the definition. Like in our sessions, you can see many students, many of our friends were asking, sir, what is full binary tree? What is complete binary tree? And I can remember, I am sorry, I could not answer that. Actually, I have seen that question, I could not answer. Somebody asked, what is rooted binary tree? If that student is on live today, for that student I am telling, I am sorry guy, I have seen it but I forgot to answer that question. Rooted binary tree means root is only allowed to have 2 children. Only root can have 2 children. All the other nodes can have either 1 or 3. So that's not a binary tree, that is called rooted tree. So for a rooted binary tree, only 1 child is allowed. Root is allowed only for having 2 children. Intermediate nodes are allowed to have 1 children. Leaf, however, will not have children. So this is what rooted means. Okay. Further information, you please go into the details of it. Okay. So trees definitions, you try to understand the definitions. Then binary search tree. For binary search tree, you try insertion, deletion. Inserting an element, deleting an element. Okay? And please remember this again, for a BST, in-order traversal will come always. BST is the resemblance of in-order traversal, and that too in the ascending order. BST's in-order traversal always gives the elements in ascending order. This point you remember. Okay? Then heap. Max heap, min heap, yesterday we have seen. Max heap, what is it? Min heap, what is it? For heap, everybody max heap, min heap means parent should be big. Min heap means parent should be small. That is okay, guys. For max heap or min heap, satisfying the complete binary tree property is important. Many people overlook that or don't practice that. That you are supposed to practice that. Why we are maintaining it in the array form? So why we are inserting here only? Why we are deleting only root element? So this kind of analysis if you do, you will get a clear clarity. That clarity gives you confidence. Not overconfidence, of course. That clarity gives you confidence. That confidence gives you time management. Simple. Okay. Now Now let's move to next. So trees means this is what basically you are supposed to focus on. AVL tree, red black tree. Okay, I know they are, but guys, probability is less. And if you know those AVL tree, red black tree, fine. I really appreciate if you already know, because you might have realized they are little complex in terms of programming, in terms of operation, in terms of analysis. They are little complex, time taking. So probability is less. Even if you get by chance, you may get 1 mark, you may get 1 mark question, or if it is very bad, you may get 2 mark question, not more than that. 1 question, that is least probable. Okay. So tree traversals, in order, pre-order, post-order. So you try practicing those traversals. I know everybody feel like they are easy, but I already told you, practice. Still you know, you practice. Now, as many people are waiting, these are the time complexities, guys. So I recommend everybody not to copy this because it takes time. Use the technology. Use the technology. Take a snap. Take a snap. Or those who are watching from the app, from your mobile, take a screenshot. So array. Sir, this much table, how to remember? Just analyze it. Array, access take 1. You can access because direct index is there at O of big O of n time. 1 time you can access any element. But search, insertion, any other operation takes O of n. Similarly, stack. So I have presented it. Again, I don't read and give you the feeling, bore feeling. So you just take a snap of this and just somebody give me indication to move to next. I'll move on to next. This is next one. Q. So here you might have noticed singly linked list insertion at start, at end I have written. There is at middle, means at some position, that is equal to at end. Like at end is equal to at middle. How much time is needed to insert or delete an element from the end? That is equal to inserting or deleting at the middle or certain position. Okay. Doubly linked list and binary search tree. Very easy. Binary search tree, any operation, big O of n. Guys, again don't ask me why. I already told you I will be presenting what is what in the current session. Okay. And this is important. In heap, we have 3 types again: binary heap, binomial heap and Fibonacci heap. So if you want further information about them, you can refer or go into the details. And mostly this is what we get in our GATE, binary heap, of course. But try to know this binomial and Fibonacci heap. That is also very simple. As you know, Fibonacci series, it is something related to that. Heap and Fibonacci series are related to that. Like Fibonacci series you implement as a heap, min heap will form, and you try to traverse from the reverse, max heap will form. So you will get to know if you get into the details. Okay. So I am just presenting again all this. This is for array and stack. If anyone missed any slide, now you can. And this is for queue and singly linked list. And this is for doubly linked list and binary search tree. Okay? And this is for heap. That's all, guys. So data structures quick revision is done. And now algorithms. So the weightage of algorithms, of course, considerably less. But DSA is very deadly combination, guys. Some questions you can't identify, is it a data structures question or algorithms question. That's a very, very thick bonded subjects these two are. So always try to prepare both together. Okay. So you will get bonus 4 marks. Now, so what to prepare? From algorithms, you should prepare or you should remember algorithmic based questions. Mostly you can answer from the remembrance. Okay. So time complexities for these 4 basically. I know branch and bound technique is also there, but I suggest you just go with only these 4: dynamic programming, greedy method, backtracking, divide and conquer. I have ordered according to predicted order. This is weightage order. Yeah, I have written that here. Topic wise, weightage wise. What are the topics? And then hashing. And then graphs, DFS, BFS. That's it. So you need not to again solve all this traveling salesman or optimal binary search tree. In academics, they are very good questions, no doubt. Algorithms is very, very good, beautiful subject. But for GATE, you need not to really practice those algorithms by taking the examples, because in GATE such questions will not come. From algorithms, this is only the possibility, guys. This is only the possibility. You may get a question from hashing, graphs, time complexities of these 4. Okay. Himadrika Sinha, just time complexities means already in the data structures I said recursion. For recursion I said time complexity of this recursion based programs. So there I have already covered that. Okay. Now first, dynamic programming has hundreds of applications, guys. Using dynamic programming technique, you can solve many applications effectively. So I am presenting most common, mostly asked or mostly predicted applications here. Okay. So for this I have done much work, much homework, guys. Much homework for presenting these popular applications. So I might not be 100% accurate. I understand. If it helps you in any way, I will be happiest person. Okay. LCS, Sushma, LCS problem, that also comes under DP, but LCS is more important for competitive coding questions. LCS, LIS, longest increasing subsequence, longest bitonic subsequence, they are important for what this IT written tests, but not for GATE. Online coding exam के लिए that LCS problem is important. Okay, so guys, so have you captured it? Dynamic programming, subset sum problem, 01 knapsack, Bellman-Ford. What Bellman-Ford again? See, I have a small silly doubt that you might just remember the algorithm Bellman-Ford without knowing for what it is. So just with that doubt, I have put for what it is used also, because this is important. One year you have got this in the match the following in one of the GATE years. Bellman-Ford is used for what? So with just a small doubt, you might miss that. I have presented that also here. Similarly, Floyd-Warshall algorithm, which is for all pair shortest path, matrix chain and OBST. They are the time complexities. Here, if you don't know what is this, it's a knapsack problem. N is the number of elements, W is the size or weight of the knapsack, capacity of knapsack. N is the number of elements. Okay? And I believe you can understand this. V is vertices and E is edges. Then greedy method. Guys, capture it. Greedy method. Job sequencing with deadlines, Huffman coding, Prim's algorithm, Kruskal's, Dijkstra's, traveling salesman problem, fractional knapsack problem. Guys, here some problems can be solved using multiple techniques, like fractional knapsack. It can be solved using dynamic programming. It can be solved using greedy method. It can even be solved using backtracking. But which gives effective, which is effective means greedy method. So I am presenting the effective one here. Naren, what is mean by load factor hashing? Naren, if you know hashing, then only you will understand what I am telling. Suppose there is a hash table of size 10. Using the hash function, you are able to fill six cells of hash table you are able to fill. Due to collision, you could not fill some other, let's say. There is no collision resolution technique. So what is the load factor? 6 out of 10. 6 by 10. Simple. Block factor. Block factor means how many elements got this collision with other elements. Those elements out of total is called block factor. Like out of, let's say there are 8 elements total. 6 you could place without any collision. The remaining 2 are colliding with the existing elements. Let's say there is no collision resolution technique. So 2 by 10 is the load factor. Block factor, sorry. Okay, shall I proceed to next? Backtracking, guys. Time complexities of backtracking are so important, so important. So here you can see greedy method is solved using Kruskal's algorithm and backtracking also. And if you observe the time complexity, it is same. So as both are giving you the same performance, I have presented for both. Okay? N-queen problem, Sudoku, Hamiltonian cycle, M coloring problem, printing all permutations of the string. Guys, if you see this, Sudoku, O of n raised to n raised to 2. That means O of n raised to n square. Okay? Then divide and conquer. Divide and conquer. These are all worst case time complexities. Worst case time complexities, these are all. So guys, I tried filtering as much as possible because I may present 20-20 applications for every algorithm, but I am not here for that. I am not here for that. I really wanted to give you what you are not supposed to miss. So at least by preparing this, I believe at least in the worst case, you will definitely able to boost your marks at least by 5 or 10. At least by 5 or 10. You are already done for, let's say, 40 marks. Let us say 40 marks. And with this score booster series or with this particular session and tomorrow's session, definitely 10 more marks will add up, because I am presenting the mostly expected topics. So definitely if you see this, you will try to revise those things. So obviously the work is done. Then graphs. Graphs have only BFS, DFS important. Breadth first search, depth first search. Guys, a misperception is there are graphs even in the discrete maths also. And by looking some question like a graph is given, the minimum number of colors required for this given graph, such questions, some students are thinking like it's a kind of graph coloring problem. It's a part of algorithms. In our GATE syllabus, that dimension of graph coloring problem need not to be addressed. That comes under discrete mathematics. So there is some conflict like this. So try to understand that. And from graphs of algorithms, breadth first search, depth first search. So let me just quickly tell, because I have not discussed this also at any given time. Let me take a graph. So you know graph means it can have cycles, loops. A, B, C, D, E, F, let's say a graph is given. Here I am not trying to draw any minimum spanning tree. I am not trying to draw any minimum spanning tree, so I have not given any weights, because minimum spanning tree to discuss, it's again a big topic. So let's say I want a BFS, I want a DFS, breadth first search traversal for this, depth first search traversal for this. So always remember, breadth first search always use Q, depth first search always use stack for programming implementation. Okay. So for this, how I can draw the breadth first search means, take a queue. Now you can start with any node. Let's say I have taken A, I am starting with A. Add it to the queue and draw it in the tree. Draw it in the tree. Now, what you are supposed to do, explore A. Exploring A means just add all the nodes that are connected to A directly. In which order? In any order. That's why for any unweighted graph, many BFS are possible. Many breadth first search are possible. That's why we have got the minimum spanning tree concept. There we will compare the weights in minimum spanning tree. Here, as they are unweighted, just you can add them in any order. Let's say I am adding here B. What other have? C. What else? D. What else? F. Do we have anything? B, C, D, F. Now go to next. Try to draw what we have. So B, C, D, F. A is done. Now go to the next element in the queue and try to explore it. So B has C. Now you observe C is the node which is already covered. So programming wise, how we check? If C is already existing in the queue, that particular edge we may neglect. In minimum spanning tree, we will compare with the weight. Okay. So B with C. B to C already covered, C is already covered, and that's it. There is only one edge. Then explore C. C to A already covered. C to F. C to F, as F is already covered, no need to draw it again. C to E, yes. C to E. C to D. C to D. D is the node which is already covered, so not required. So C to A, F, E, D already over. Now explore D. Explore D. So D to A is already covered. D to F, D to E, D to C. So if any node is already added, then you need not to consider. So then D is over, then F. F to A, E, D, C already all are over. So this is what the minimum spanning tree, and what is the order? That's last. So you can say A, B, C, D, F and E. This is the breadth first traversal. Sir, is it only possible? No. That's what I am telling. For unweighted graph, many valid BFS traversals will be possible. Okay? Many valid BFS traversals. Now, for the same, if I want to draw DFS, depth first search. So take a stack. Start from any node. Let's say I am starting from A. I am starting from A. Now, explore A such that take any one node. You can't explore completely. Partially you have to explore. So A to B. Now until you reach a leaf or until you reach some point, you have to keep exploring. So B to C. C to F you may, C to E, C to D. Let's say I am exploring C to D. D to E. E to F. A to B, B to C, C to D, D to E, E to F, F to A. So we have already visited A, so there we end. This is one possibility. Like this you may say A to B, B to C, C to F, C to F. If you go for F to A, here you stop. Try to understand. C to F, F to A, here you stop. So A is explored, B is explored, C is explored, F is explored, and F one edge is over. Then if you go from F to A, you will stop. So F to C already covered. F to D already is there? No. So you can say F to D, F to E, F to E. So F is over. So you will start from F. Here A is not supposed to be deleted. You will start from the top of the stack element. You try to explore it completely. Remove from the pop from the stack. Like this, in this order you will draw DFS, depth first search. Understand? So this is what the way, guys. I know I have not explained it completely. With multiple examples, if I explain, then you will get much clarity. As it's a quick revision, I am just trying to give you an idea. So graphs means you should practice BFS, breadth first search, depth first search. Try to practice with the maximum complex questions. Okay? That's all, guys, for today. So today we have presented, I have presented what topics from DS, what topics from algorithms you are supposed to prepare for sure, what kind of questions you are supposed to prepare for sure, and what is the expected weightage in this year GATE 2020 from DS and algorithms. And I try to quickly revise those topics also. Okay? I think this session helped you. So if you really like this session, please like the session. At the same time, try to share this to many of your friends, all of your friends that you have who are writing the GATE. Even if they are not writing the GATE, it may help you in at some moment. They may understand what are important, at least in academics, isn't it? So try to explore this as much as possible. Okay, so keep preparing, guys. You just have 4 more days. As I said, after this session, you sit, like relax for 10 minutes and sit with every subject. So are you prepared for this topic? Are you good at this topic? So you try to make a separate sheet from the topics that I have given, what you are good at, what you are not good at. So try to concentrate. Finish DS and algo revision today. And tomorrow, in the same way, I will, because tomorrow we will be discussing computer networks, computer organization, operating systems, 3 subjects. As they have some formulae, I will try to give some formulae also tomorrow, because from DS, except trees, there are no more formula. And trees formula, yesterday's session I have already given, isn't it? So if anybody missed yesterday's session, please refer that. Trees formula, yesterday I have already given it. Okay? For CO, CN and OS, I will revise quickly tomorrow. So see you all, guys, in the tomorrow's session. Keep preparing. Don't relax for these 3 days. On 7th you can relax. On 7th you please relax. So today, tomorrow and day after tomorrow, don't please relax. Work, revise, write mock tests if possible. Tomorrow we have mock test, guys, so don't forget that. Tomorrow we have Gradeup mock test. So please give the attempt to mock test, and please keep preparing. Okay guys, that's all. Good night everybody. Have a nice sleep, have a nice food, prepare thoroughly. Okay. So be happy. See you tomorrow guys. Prep smart, score better, go Gradeup. Thank you.